Hey everyone, so today we're going to be doing notes on section 2.8, which is graphing linear inequalities. So go ahead and pause this and write it down. All right, so just a reminder, I abbreviate inequalities as INEQ, so that'll be abbreviated throughout the notes. So in order to graph these, step one is to graph the boundary line. So whatever the equation is that you're given, or the inequality, graph it as if it was an equation, the same way you would using the slope and Y-intercept. The only thing that's going to be different is now whatever your inequality is going to determine if it's going to be a solid or dashed line. So if it is greater than or less than, that means that anything that's your solution is either greater than or less than that number. It's not equal to is not included. So this is the equivalent of doing that open circle on a number line. We're going to be doing a dashed line. Now, when the solution is included, greater than or equal to, less than or equal to, it's a solid line. This is equivalent to doing that closed circle on the number line. So that's the first step, determine if it's solid or dashed. Then step two, once you've graphed it, test a point that's not on the line to determine if it's a solution to the inequality. Once you've done that, if it is a solution, you're going to shade the direction of that point, because that means that point works for your inequality. It is true. So you're shading where that true point is. But if it's not a solution, you're going to shade the other direction, because that means the point you plugged in does not work in your inequality, which means it is not a solution. So let's go ahead and look at an example. I'm going to start with one of these special cases where we don't have an x value. So our special cases are these horizontal and vertical lines, the y equals and x equals equations. So we have the inequality y is less than or equal to -3. This means it's going through the y-axis, which is the straight up and down, which means it is going to be a horizontal line. Now, the way I remember the difference between horizontal and vertical is horizontal is like a horizon. If you look out at the horizon or sunrise or sunset, your horizon is flat. So a horizontal line is flat. Now, saying that this is -3 means it's going to go through the point -3. It's going to be a horizontal line that goes through that point, -3. But before I actually draw this line, I need to determine, is it solid or dashed? What do you think? Good, you should have said that this is going to be a solid line because it has the or equal to. So let's go ahead and draw a line. Now, last week, you got to see my cool alligator ruler. Now you get to see my weird little McDonald's ruler. I think this came in a Happy Meal like forever ago, but it's cool because it's bendy, so I keep it in my pencil case. And it's like one of those weird, it's hard to see on the video, but one of those things that like when you move it, the faces move. The clown Ronald McDonald is kind of creepy, but it's nice because it fits in my pencil case because it bends. All right, so let's go ahead and draw a line. Now remember, this is a solid line because it's or equal to. All right, now for this inequality, it's everything less than -3. So this one would be a little bit easier to guess. It's going to be everything that's below the line. But for the sake of testing a point and plugging it in, I'm going to go ahead and do that for this example. So the point that I always like to plug in whenever possible is 0, 0. Just because it's nice, it makes everything cancel out. If it's multiplied by anything, fractions, anything like that, 0, 0 is always really nice to plug in. So I'm going to choose the point 0, 0. So when I plug that in, I get 0 is less than or equal to -3. This is a false statement. I have a color pen. This is false. So what that means is, let's scoot that down a little bit, is we shade away from 0, 0. Or in other words, below the line. We shade away from this point. So we're not going to shade on the side of the line that includes this point. We're going to shade down here. You can either color that shading in really nice and make it go all the way to the line and fill this entire space in. I do that when I get into graphing systems of inequalities, but for the sake of just drawing one line, it's pretty obvious I'm shading it on this side of the line. So it doesn't have to be perfect. Let's look at another example. So we've taken care of our special case, the horizontal and vertical lines, but let's do one now where we actually have a slope and y-intercept. All right, so first thing we're going to do with this, determine if it is solid or dashed. And it is, good, you should have said solid. So this line is going to be solid. Now we need to graph this using our slope and y-intercept. So my slope is -3, or in other words, -3/1. So that's our rise over run. And then my y-intercept is 0, -1. So let's go ahead and plot the y-intercept, 0, -1. And then I can either go down 3 to the right 1, down 3 to the right 1, or I can make the 1 the negative number. So I go up 3 to the left 1, up 3 to the left 1. And remember, I just want you to have at least 3 points, because if you only have 2, it's really easy to draw your lines so that it's not going through the 2 points correctly. So again, this is a solid line. Now, for this one, it's a little bit harder to tell what direction we would shade it. It's greater than or equal to, so if I had to take a guess, I would guess I'm shading on this side of the line, but I still want to double check. So what I need to do is choose a point. Now again, what I said in the last example is I always like to choose 0, 0 whenever possible, but depending on how big the graph is and how big your grid lines are, it might be really hard to tell that the point 0, 0 is not touching your line. On mine you can, because the grids are far enough apart. But because it's so close to the graph, I'm going to choose another point that's really easy. I could choose 1, 0. I could choose 0, 1. I'm going to choose 1, 1. Just choose something that is not on your line. Now, I could have also picked a point that was over here, but all of these are negative numbers, and positive numbers are just nicer to work with, in my opinion. So I'm going to choose 1, 1, and go ahead and plug that in to double check, and then push play. Or I'm sorry, pause this to double check, or to plug in that point, and then push play when you're ready to check your answer. So after you plug that in, you should have gotten that 1 is greater than or equal to -4, which is a true statement. 1 is bigger than -4. So what we are going to do is shade in the direction of the point we plugged in. I abbreviated point as PT. So we plugged in this point here, which means we're going to shade on the side that includes this point. So we are going to shade on this side of the line. Again, since I'm just shading one line, I'm not making this super nice and pretty and perfectly filled in. You'll understand in the next lesson that we do when we're doing a system of inequalities, I'm going to shade it in really nicely with colored pencil. So the last thing I'm going to answer is whether it's shaded above or below, and it ended up being above. For the last example we're going to be doing, if you notice, the problem that we're given, this is not in that slope-intercept form. It's not in the y = mx + b. But I can still determine whether it's solid or dashed. So which one will it be? Good. You should have said that this is going to be dashed. You get that just from looking at the inequality. But we need to change this so that it's in the correct form so that we can graph it. So I'm going to go ahead and rewrite this. X plus 3y less than 9. What do I do first to put this in the correct form? Good. You should have said subtract x from both sides. So 3y is less than. Now, because I want this in mx plus b form, I'm going to write the x term first. And then I need to divide everything by 3. Now I'm dividing both sides by a positive number, which means my inequality stays the same. Now instead of writing this as negative x over 3, I'm going to write it as negative 1/3 x, so that I have my defined slope out in front, and then plus 3. So now that it's in the right form, I know that my slope is negative 1/3, and my y-intercept is 0,3. Oops, that's underneath the line. Let me move that. All right, go ahead and pause this video and graph your line. So your line should look something like this. Now, if you accidentally drew this as a solid line and then went, oh my gosh, shoot, this was supposed to be dashed. If you drew it in pencil, just go back and erase little tiny spots to make it a dashed line. Now, something that I do want to say about doing dashed lines, I don't care how close together your dashes are. It can be like super, super small little dash lines. Or if you prefer doing like really big dashes, you can do that. Just don't make it like little dots. Make it at least little tiny lines to make it really easy to tell that it's dashed and not solid. Last thing we need to determine is this shaded above or below? So again, this is less than, so I could take a guess and say, I'm guessing it's going to be down here. I'm guessing we're going to shade below this line because it's less than, but I'm still going to double check. So I'm going to choose the point 0, 0 because that's nowhere near touching my line, so I know I'm safe to plug in that point. So let's choose 0, 0. Whoops, still can't see that. Oopsies. Sorry. I don't know why I can't make these little bars go away at the bottom of the video. The document camera thing. All right, so I'm going to choose 0, 0. Go ahead and plug that in, push pause, plug that in, and then push play when you're ready to check. All right, now I purposely did not tell you which equation or which inequality to plug it back into before you started. And the reason for that is because it doesn't matter. This equation is equivalent to this equation. They're just written in different forms, but they are the same exact line. So I showed you plugging it into both just so that you can see the number that you get is different, but it's still a true statement no matter which one you plug it into. So because it is a true statement, we are going to shade in the direction of 0, 0, because that's the point that we plugged in. Now I'm going to add a separate little note up here. Plug the point into either inequality. Does not matter which one. So I'm shading towards this point that was true. Because this one is a huge space, I'm not going to try to do that all in one stroke. I'm going to do that. All right, that is officially the end of our notes. Have a good rest of your day.